So my name is Professor Sanjeev Gupta. I'm here at Imperial College in London, but I actually grew up in Dehradun in India. I was born in Agra, but I've lived in England since I was about 5 years old, and I'm now Professor of Earth Sciences at Imperial College in London. I'm a geologist, and actually initially my research and teaching was focused on working in the Ganges Basin. I worked on rivers in the Ganges Basin, I still do. I look at groundwater problems, pollution, and river behaviour. But about 10 years ago, I transitioned my research from rivers in India to rivers on Mars, ancient rivers on Mars, rivers that existed billions of years ago. And what we can see in this image, this is a place called Jezero Crater, which is, this is the NASA rover Perseverance, and I work on the science team of the mission, and I'm also part of the team that's doing strategy for the mission. And what this mission is doing is it's collecting rock samples by drilling into the Martian rocks for future return to Earth. And what we're hoping to discover was the evidence for life billions of years ago on Mars. And it's very difficult to tell that with a robot on Mars, but we're hoping that in Earth laboratories we'll be able to detect organic matter and also reconstruct the history of Mars through time. So what you can see is this is the rover. You can see the cameras of the rover up here. And inside the rover we have a whole array of instruments. And the main instrument that you can't see in this is that we have a huge arm that actually drills into the rocks on Mars and collects cores of samples about this big. And these are put inside the rover, and what we're doing is they're put into a special tube, and those tubes are being deposited on the surface of Mars at specific locations where in 8 years' time they will be collected by the Mars Sample Return Mission. This is probably the most expensive and complex space mission ever. And what you can see here is one of the tubes that's been deposited on the surface of the planet here. This tube will lie here for 8 years, and it's about this big. It's about the size of a whiteboard marker when we draw on a whiteboard. And what will happen is that a mission in 2029 will land on the surface of Mars, and there'll be a little helicopter that will go and seize these tubes, grab them, and put them into the return vehicle. All the samples will be put together into the return vehicle, which will be launched into Mars orbit. This will then circle around Mars in Mars orbit, and then there'll be another mission that will grab these samples and return them to Earth by 2033. And then they will be available for analysis in Earth laboratories. And I would say that these are the most expensive rock samples that will ever be collected, but they will actually transform our understanding of Mars, which is a really interesting planet because it has a very different history to Earth. We have oceans, we have rivers and lakes, we have abundant water, we have plants and creatures. Mars is a planet that died about 3.5 billion years ago. So early in its history, about 3.9 to 3.5 billion years ago, Mars was considered to be warm and wet, with rivers and lakes and maybe even an ocean. And it just died. And we don't really understand the reasons for that. So it's interesting to study why these two different planets have completely different histories, different trajectories, and these secrets will unleash this for us.